Welcome to Math 120 in-class activity 2D, a geometric problem. In calculus, one often encounters problems like the one shown in the box. I want you to read the problem, but do not solve it now. Just think about it and answer a few questions. Find the dimensions of the cylinder of the maximum volume that can be inscribed in a cone of height 12 inches and base diameter 8 inches. And so you have a cone of height 12 inches and base of diameter 8 inches. Later in this activity, we will approximate the solution to this problem. For now, think about the following questions. What are the minimum and maximum possible values of the radius of the cylinder R? As R increases, what happens to the height of the cylinder if it remains inscribed within the cone? I want you to think about this problem, proffer a solution, and we will take it together. Pause your video and do this and come back to look at it. Now let's think about a few solutions or what we can see. Now we see that the radius of this cylinder must remain within the radius of the base of the cone, which is going to be 4. Taking that the diameter is 8, so the radius is 4. And so the radius of this cylinder cannot be greater than 4 or go less than 0. Of course, we cannot get the radius to be less than 0. And so the radius is going to remain within 0 and 4 inches. And as you see, as the radius increases, the height would have to make way for it. And so, for example, if the radius is somewhere here, if it increases from here to somewhere there, then the height would have to come down to make way for this radius from here as it increases to somewhere there. So this is going to be our new height. As the radius increases, this is going to be our new height. And so we have the radius somewhere here. Objectives for the activity. You will understand that similar triangles may be used in combination with geometric formulas in mathematical modeling. You will be able to determine the dimensions of a cylinder inscribed in a cone that produces the greatest volume. Continue working with the geometric problem posed in question 1. Use similar triangles to determine the height h and volume of the inscribed cylinder when r equals 0, 1, 2, 3, 4 inches. Record your results in the table. B. Of these 5 inscribed cylinders, which has the greatest volume? And then part C. What are the height and volume of this maximal cylinder? I want you to think about these questions, pause the video, and make an attempt, and then let's look at the solution together. Now, remember the cylinder and it's inscribed in the cone as shown here. The total height of the cone was 12, and the base diameter of the cone was 8. And so the radius of the cone from here to the center is going to be 4. This is our cylinder inscribed in the cone as shown. Let's assume that from here to there is the radius of the cylinder. Now you can see we have a small triangle at the top here. And also, we can get a big triangle out of that. Now what I want to do is that I am extracting this part of the triangle. And that is it. And so this from here to there is my height of 12. From here is my small triangle at the top, which has a radius of r. If this is the height of the cylinder, then the height of the small triangle at the top is going to be 12, this total height, minus the height of the cylinder. And that is what we have here. Now the radius of the cone was 4, and so the base of the cylinder is going to be equal to the radius, which is 4. By similar triangle, we see that the height of the bigger triangle, this big triangle, which is 12, divided by the height of this small triangle, which is 12 minus h, is going to be equal to the base of the big triangle, which is 4, over the base of the small triangle at the top here, which is r. When we manipulate this, we realize that h, the height of the small triangle, or the height of the cylinder, becomes equal to 12 minus 3 times the radius, right? Now, and so what we want to do is that we want to find the height when the radius is 0, 1, 2, 3, and 4 inches. And so all we do is we put r to be 0 here, and we are going to get h, the height, to be 12. Now we know that the volume is always given by pi r squared h, the volume of the cylinder. And so once we have our r and we have our h, and pi is a constant, we just slot this in and we'll calculate the volume. Now when the radius is 1 and we put r to be 1, we have 3 times 1, which is 3, and 12 minus 3 is 9. And we use that also to calculate the volume. And so by similar reasoning, you can get all these heights and these volumes. Part B, of these 5 inscribed cylinders, which has the greatest volume? Now, as you can see, the greatest volume occurs here at r equals 3. So that is the greatest volume. Number 3, set up and find an approximate solution to the geometric problem. Write a formula expressing the volume V of the inscribed cylinder in terms of the radius r of its base. Write your answer using function notation. Now, what we want to do is that we want to find the volume of our cylinder in terms of the radius. And this is what we have to do. We know that our height, we have calculated our height to be equal to 12 minus 3r. And the volume of the cylinder is given pi r squared h. And so all we want to do is we want to replace this h by 12 minus r. So the volume in terms of r is just going to be pi r squared and then 12 minus 3r. Now when we expand this, we are going to get 12 pi r squared minus 3 pi r to the power 3. That is that. Now part B says that we should grab the function from part A and estimate the radius of the cylinder of the greatest volume. Now when you grab the function, this is the nature, and you will see that the radius for the maximum is occurring around 3, as you can see here. It's occurring around 3. Now, what are the heights and volume of the maximal cylinder? First of all, it says estimate the radius of the cylinder greatest volume. So now, using calculus, what we can do is that we know that for the maximum, dv the r should be equal to 0. And when we differentiate this, we are going to get 24 pi r minus 9 pi r squared is equal to 0. Now this gives us 3 pi r. 3 goes into 24, 8 minus 3r is equal to 0. Now when we equate this to be equal to 0, we get r to be equal to 0, which of course cannot give us a maximum. And so we are going to get 8 minus 3r is equal to 0. And that gives us r to be equal to 8 over 3, which is almost 2.67 inches. Now using that, we can then get the height and the volume of this maximal cylinder, which I will leave as an exercise for you. And these are the answers. Thank you for watching this video.